All right, what do we got here? 6-8, number 3. They're asking for a final velocity, so big clue that we should use an energy approach. There's a spring involved, also a big clue to use an energy approach. So let's see, what do we got? We've got spring with spring constant K attached to block with mass M on a frictionless ramp attached to a reel with radius R and moment of inertia I. Okay, and then what we do is we reel it in. So it starts in this position where the spring is unstretched. We then reel it in up the hill to this starting position. So this is actually the initial position when it's all wound up and the spring is stretched. All right, we then let it go and the spring pulls it down the ramp and gravity pulls it down the ramp, and we want to know what the speed is here. This would actually not be the maximum speed because the spring will keep pushing back, slowing it down at a higher and higher rate. So what do we got? So we've got a height h based on the distance d that we reeled it up the ramp. So we can put h in terms of d. So h is d sine theta. And then we're going to just set up our initial energy and our final energy equations and solve them, set an equal. So initial energy is gravitational potential mgh and elastic potential 1/2 kx squared. The big parts of this problem are putting h in terms of d because that's given. So d sine theta goes in for h. And the amount of stretch for the spring is also d, the amount that the block went up the ramp. So there's your initial energy. Boom. The final energy then it's all the potential's been released. It's all kinetic at this point. And so we've got the translational kinetic energy of the block and the rotational kinetic energy of the reel. And so we're just going to set those equal to our final energy. So 1/2 I omega squared and 1/2 mv squared. Now in this one, it was a little weird to me that they didn't just give us the mass of the reel. They just gave us the I, which is whatever. That's also kind of typical too in some AP problems. If they don't want you to really worry about what the moment or shit is, they'll just say it's I. Or you'll find things in terms of I. Maybe they move it and then you say, oh, it's 2I. So anyway, so you got the kinetic energy of the reel, it's rotating, and then you've got the kinetic energy of the block. The only thing we have to do is convert the linear translational velocity into the angular velocity, and we're going to do that with tangential velocity equals omega r. So we're just putting an omega r there. Hopefully that makes sense, right? Because this block is moving the same as this point on the outer edge of the disk, and so we've got our conversion between tangential velocity and angular velocity, omega r there. Set your initial energy equal to your final energy and solve for omega, and that's it.